So here we have another chapter. Motion and time, which is one of the important topic for the exam sake. In the examination, it may be carrying few marks. So here in the previous class, I already told you what is motion and what is rest, how to understand this. So motion can be defined. Excuse me. So sorry, I couldn't take you the class up to now. Now we will discuss motion. What is motion? The definition for the motion is, see here, object is said to be in motion. That let me request and a text. So an object, can you see, an object is said to be in an object is said to be in motion if it changes its position with respect to its surroundings in a given time. Okay, if the object is not change, if an object is said to be rest, if there is no change with respect to its surroundings in a given time. Here we are using two terms. One is motion and another is time. So we are comparing the position of the object with respect to time. We are comparing the object position with respect to the time. Based on the time, if an object is moving with its surroundings, then we say it is in motion. Or if it is not moving, we say it is in rest. Both rest and motion are relative terms. It has to be compared with an object or a surroundings. And if a body, so if a body is moving, here you see a diagram is given. The diagram. So here a car is moving with respect to tree. And here we say that here the car is moving. Let us take simple example. With respect to the tree, car is moving. But with respect to the car, it seems to be tree is moving. Because the person is there only in the car. కార్లో ఉన్న ఆయనకి కార్లో ఉన్నట్లే కార్తో కదులుతున్నట్లు అనిపించట్లేదు. The observer point is this. If it is surrounding is car to the person, with respect to the surrounding of car, we can say that the object is not moving. Object is not moving. కార్తో పోలిస్తే ఆయన కదులుతలేడు, కానీ బయట చెట్టు కదులుతున్నట్లు అనిపిస్తుంది. కానీ వాస్తవానికి, so with respect to the tree, car is moving. So from this, we can say that the rest or the motion are relative words. Okay, that we can say. So here an activity is given, the same thing what we are going. Which one is true? Look at the picture, state which of the following statement is true. One statement ikkada ichinaru chudandi. The distance between the driver and the car changes. Is it true? The distance between the car and the gate of the house, of course, when the car is in motion. There is no change in the position of gate of the house with respect to its surroundings. Surroundings తో పోల్చినప్పుడు గేట్ యొక్క ప్లేస్ మారట్లేదు. So all these things we are giving an example, but these are relative words. Okay, this change in the scene you view through the window indicates that car is moving. However, your position with respect to the driver of the car remains same. So that is okay. Now you are observing some different kinds of motions. You see, a boy is, what to say, sailing in a boat. A boy is sailing in a boat in a river. రివర్ బ్యాంక్ అమ్మట ఆయన పడవను నడుపుకుంటూ పోతున్నాడు. ఇక్కడ ఊయల అటు ఇటు ఊగుతుంది, అంతో ఎంతో ఊగుతూ ఉంది. సైకిల్ రోడ్ మీద చూడండి, వంకర టింకలు తిరుగుతూ సైకిల్ పోతుంది. ఇవన్నీ కూడా డిఫరెంట్ టైప్స్ ఆఫ్ మోషన్స్. సో హియర్ ద బోట్ ఈస్ మూవింగ్ లీనియర్లీ. Here the cradle is moving in different directions, to and fro. Cycle moves in a curved motion, different motions. So there are different types of motions we have. To understand this, we use the word uniform motion and non-uniform motion. Uniform motion and non-uniform motion. What are these? Let us try to understand. We always try to compare the position of the object with its surroundings with respect to time. With respect to time. So in a uniform, what are the word meanings of uniform motion and non-uniform motion? Let us try to understand. Okay. What is uniform motion? That we have to understand. So in uniform motion, in uniform motion, to definition, in what way we can give the definition? If the speed of an object moving along a straight line, if a move, now we are trying to understand uniform motion. What is uniform motion? That we have to recapitulate the said meaning for that. If the speed of an object moving along a straight line with a constant speed is said to be in uniform motion. The speed of a vehicle or an object, speed of an object moving along a straight line with a constant speed said to be in uniform motion. So most of the children are asking, speak louder. I didn't. Still, is my voice very low? Okay, I'll try to speak louder. If the speed of an object moving along a straight line with a constant speed is said to be in uniform motion. So how to understand this? Uniform motion, how to understand? So here, let us take a simple example to understand this. A table has given to you. Okay, a table has been provided to understand this. See, 0 seconds, it is at 0 minutes. Object moved for 10 seconds. The difference is 10. How many meters it traveled? 150 meters. 10 seconds to 20 seconds. 150 to 300. What is the difference on a distance? 150. And if in first 10 seconds, 150 meters it traveled. Second 10 minutes, 10 seconds, it traveled once again 150. In the third also it travels 150 each, third, fourth and fifth, in that way if it is moving. In equal intervals of time, if the object is moving with a constant speed, that is, it is covering the same distance in equal intervals of time, then we say the object is in a uniform motion. The object is in uniform motion. See, now you see another table here, another table. 0 to 0, it is only traveling 50 minutes, 0. When there is no time at all, how can the object move? Always, initially, when the object is moving, time also should, motion will be based on the time. If the time is passing, the object may displace or may not displace. If it is displacing, we say in how many meters or how many kilometers it is moving in that way. See here, compare these two tables. For 0 seconds, it moved 0 meters only, but 10 seconds, it is 50 meters. Next 10 seconds, 20 minus 10, 10 seconds, here 40 meters only it is moving. But next 10 seconds, 30 minus 20, 10 seconds, the gap is. Here it is moving 90 meters. See, here the object is moving for equal intervals of time. The motion is not constant. The travel part is not constant with respect to car beat. The car beat is not, it is not uniform. If an object is not covering constant distances in constant speeds or a difference of speeds, then we say that object is not in uniform motion. If the object is not uniform motion, then we say that its motion is accelerated. That's what we are trying to understand. Okay, motion, uniform and non-uniform. I think you are aware of it. If a body covers equal distances, in equal intervals of time, then we say it is body is in uniform motion. But if a body covers unequal distances. Student, don't get confused. Unequal. It is not equal. Unequal distances. Then we say it is object is not in non-uniform. Object is in non-uniform motion. Okay. Now let us try to understand. You observe so many kinds of motions around us. So we shall see which are non-uniform motion and which are uniform motion. See, identify the uniform and non-uniform motion here. Movement of a hands of a clock. ఒక క్లాక్ లో హ్యాండ్స్ ఉన్నాయని అనుకుందాం. అవి ఏమైతాయి? మూమెంట్ ఆఫ్ హ్యాండ్ క్లాక్, ఇట్ ఈస్ ఇన్ యూనిఫామ్ మోషన్. ఏ బాయ్ సైక్లింగ్ ఇన్ ఏ క్రౌడెడ్ ప్లేస్. చూడండి, ఒక మనిషి సైకిల్ తొక్కుతున్నాడంటే ఎక్కడ గుంపుగా ఉన్న దగ్గర ఒకే స్పీడ్ లో పోతాడా వాడు? నో, ఇట్ ఈస్ నాన్ యూనిఫామ్ మోషన్. మూమెంట్ ఆఫ్ హౌస్ ఫ్లై. ఒక హౌస్ ఫ్లై ఎగురుతా ఉంది, అది ఒకసారి స్పీడ్ గా పోతుంది, ఒకసారి అంటే ఇట్ డస్ నాట్ కవర్ ఈక్వల్ డిస్టెన్సెస్ ఇన్ ఈక్వల్ టైం పీరియడ్స్. అంటే కాలాన్ని సమానంగా డివైడ్ చేస్తున్న వ్యవధిలో ఆ వస్తువు ఒకే దూరాన్ని ప్రయాణించకపోతే దాన్ని మనం ఏమంటామంటే నాన్ యూనిఫామ్ మోషన్ అని అంటాం అన్నమాట. ఆ ట్రైన్ ఎంటరింగ్ ఇంటూ ఏ రైల్వే స్టేషన్, ఇట్స్ స్పీడ్ డిక్రీజెస్. రైల్వే స్టేషన్లోకి వస్తుంది అంటే అది ఏమవుతుంది? ఆగుతుంది. ఆగుతుంది అంటే ఇట్ డస్ నాట్ హ్యావ్ ద సేమ్ స్పీడ్ త్రూ అవుట్ ఇట్స్ పాత్. ఇట్ ఇస్ టైమ్ ఈజ్ సేమ్, టైమ్ ఇన్ ఈక్వల్ ఇంటర్వెల్స్, but the speed, the distance covered by it is very lesser and lesser, decreasing. Kite in a air, kite in the air, I don't know in which direction it moves based on the wind speed. Rotation of the earth, this is also may not be non-uniform, may be non-uniform motion. Okay, now we could able to understand what is uniform motion and what is non-uniform motion. Now let us come to know, let us try to discuss the different kinds of motion, types of motion. When we discuss about motion, it is very important to be aware that there exist different types of motion and each type dependent on a particular situation. Based on the situation, let us try to observe some kinds of motion here. On road, car is moving. On road, car is moving, traveling along a straight road. Motion of blades of a ceiling fan. Motion of a needle in a running sewing machine. Student, in a running sewing machine, motion of a what to say, needle. Here fan is revolving, fan is rotating. And here in a clock, you can see the pendulum. It has different motion. It is moving this side and that side, to and fro. Based on a mean position, this moves in two directions. It moves in two directions. So there we have seen here the four kinds of motions. The first one is car is moving linearly. The second one is object is revolving around a rod. We said that is an axle, around a rod or an axle. Here in a sieving, needle in the sieving machine moves up and down, and clock in a wall clock or a pendulum clock, the pendulum moves left and right. So all these two are maybe in a uniform motion, even the fan, but the sidecar also can sometimes, if it equal, covers in equal distances in equal intervals of time. Based on this, based on the path taken by the bodies in motion, we classify motions of bodies as translatory motion, rotatory motion, and oscillatory motion. See, the translatory motion, rotatory motion, and oscillatory motion. For the translatory motion, you can see the figure here. At At B, tree is there, and at A, current pole is a signal pole, but bus is traveling from A to B in a straight path. The bus moved from point A to point B in a certain interval of time. So observe here some exercises are given in your reader. Soldiers marching in a parade. Is it a straight line or curved path? The parade takes place in a straight line. Car taking a turn on the road. Is it a straight line or curved line? Of course, it is a curved line. Stone dropped from certain height. Just we are not saying a stone thrown. A stone was thrown. No, we are saying just stone dropped from certain height. Certainly, it has a straight line path. Running race along a road. I don't know whether it is a straight road or curved road. If it is a curved road, it's a curved line. And if it is a straight road, it has a straight line. We cannot tell which is correct. A running race along a track on a ground. Certainly, it will be a curved line. In a track, when you consider, it will be in a circular way or all elliptical way. Okay. A movement of a bicycle on a road, it can be moved in any of the directions. చూడండి ఇక్కడ we are trying to classify different types of motion. But what is translatory motion? That we are trying to understand. If all parts of a moving body move in the direction of motion, then motion is said to be translatory motion. చూడండి translatory motion అంటే ఒక డెఫినేషన్ ఎలా చెప్తున్నారంటే if all parts of a moving body, if all parts of a moving body move in the direction of the motion, then చూడండి ఒక బస్ పోతుంది అని అనుకుందాం. ఫర్ ఎగ్జాంపుల్ బస్సుతో ఉన్న అన్ని పార్ట్లు బస్సు పోయే డైరెక్షన్లోనే పోతూ ఉంటే టైర్ అట్టే పోతుంది, ఆ బాడీ అట్టే పోతుంది, అందులో కూర్చున్న మనుషులు అట్లే పోతున్నారు. ఓకే, if all each and every particle in the body are moving in the same direction of the motion of the object, then we say it is translatory motion. For example, any object which moves linearly on the road or on a path or in air, wherever it is, all parts of the body move along the same path. Then we say object path. Then we say it is a translatory motion. So now next, rotatory motion. What is here? You can see the example of top and also fan. Okay, you can see the figures, fan and top, even giant wheel. So when you see giant wheel, excuse me, and globe and a clock, wheels of the car. See so many examples. What is the similarity in the motion of all these things, all these parts? That is the tires of a car or a globe, or what is this giant wheel? Oh, in all this motion in see, all are revolving or rotating around an axis. If you observe all this, while the blade of a fan is moving, the points ABC on the blade move even, so it is moving in the same path. That is, when fan is in motion, each point on the blade moves in a circular path around the center of the fan, which is fixed. సో దీన్ని మనం ఈ టైప్ ఆఫ్ మోషన్ ఏమంటున్నామంటే రొటేటరీ మోషన్ అంటున్నాం. ఏమంటున్నాం? రొటేటరీ మోషన్. సో ఇక్కడ చూడండి, డెఫినేషన్ ఆఫ్ ద రొటేటరీ మోషన్ ఈస్ గివెన్. ఏమి ఇచ్చినారు డెఫినేషన్ ఆఫ్ రొటేటరీ మోషన్? Rotatory motion means that motion of all particles of a moving body follow a circular path with respect to a fixed center or axis of rotation. Children, but how to understand rotatory motion? Rotatory motion means that motion of all particles of a moving body follow a circular path with respect to a fixed center. చూడండి ఒక ఫిక్స్డ్ సెంటర్ ఇక్కడ ఈ పాట్ మ్యాన్ ఫిక్స్డ్ సెంటర్ ఇక్కడ పెట్టినాడు. దాని చుట్టూ ఈ ఈ యొక్క వాట్ టు సే ఆల్ దిస్ మడ్ పార్ట్, ఈవెన్ ద పాట్, ఈవెన్ reams, whatever it may be. When it is in motion, all will be in circular motion along a fixed point or axis. This type of motion is called rotatory motion. So there are so many examples in day-to-day life. It is a pot is in rotatory motion, globe is in rotatory motion, fan is a rotatory motion. But when we are on to swing that side or this side, then it has a different kind of motion. When you push a ball on the surface of a table, it moves from one end to the another end, and all the particles of the balls also move along the direction. Maroka object, when it is moving, does it have only one kind of motion? Does it have only one kind of motion? Is it necessary to have only one kind of motion? No, it is not necessary to have a one kind of motion. Few objects have more than one kind of motion. For that, an activity is given, just you can go through. Motion of blades of a ceiling fan. What type of a motion it have? It will have only rotatory motion. Motion of arrow from a bow, it has only a linear motion. But sometimes they may rotate on its axis as bullets do. Okay, rotatory motion. Sorry, rotatory along an axis. Motion of the earth around the sun, it is a rotatory motion. Motion of a drill bit, చూడండి ఇది గుండ్రంగా తిరుగుతుంది, స్ట్రైట్ గా కూడా పోతుంది. And it has a translatory motion as well as a rotatory motion. And later, motion of wheels of an object. See, wheel is rotating around an axis. At the same time, it is moving along the road. So it has a translatory motion, and also it has a rotatory motion. So now we shall come to another kind of motion, is oscillatory motion, or oscillatory motion, or to and fro motion. Children, when you observe your diagrams which are given here, observe the oscillatory spelling OSCILLATOY. డోలన చలనం అని అంటాం. ఇక్కడ మనం చూస్తే ఈ బొమ్మల్లో so 4 figures you can see. So here it has rotatory motion. The fans has rotatory motion. But here it swings left and right. It swings left and right. Based on one position, it is moving left and it is moving right. Here you can see this has one side of motion. Here clock hands, they have rotatory motion. Along a fixed path, along the fixed point, based on a fixed point, all the hands rotate around it. So it is a rotatory motion. But if you see the pendulum here, this pendulum, so let us consider this is as a mean position. From the mean position, this will move in to and fro directions. It will move to and fro directions. When it moves to and fro directions, based on one mid position. This type of motion is called oscillatory motion. So same thing here, you can see one example, swing. They are playing with the swing. The swing also moves to and fro, to and fro, based on one mean position. Based on one mean position, it will be moving. It will be moving. Here the needle of seeing machine that you can see. So it also moves left and up and down, up and base along a mean position. It moves up and down. This also has Y oscillatory motion. Okay, this is one kind of these are the examples for oscillatory motion. Okay. So now we try to discuss all the three kinds of motion. One is translatory motion. The other is a rotatory motion. The third one is called oscillatory motion. Children, oscillatory motion, I don't know how the definition is given. We shall see. The to and fro motion. The to and fro motion. To means munduke, fro means venakki. The to and fro motion of an object about a fixed point, always following the same path. This is very important. Always following the same path is called oscillatory motion. Oscillatory motion means the to and fro motion of an object about a fixed point, always following the same path is called oscillatory motion. Okay, you can mark some, you can identify some kinds of motions here. ఈ క్రింది వానిలో oscillatory motion ఏది? A spinning of a top. Does a spinning of a top oscillatory motion? No, it is not oscillatory motion. Is my voice not audible? So many children are saying, sir, say louder. I am saying louder only. As usual, is it not audible? Dear, one of you respond, please. Today, many Hanmant Reddy, always he is writing, and also Chandrasekhar. Both are asking me to speak louder. Is it not audible? Ringing of bell. What? For it is a oscillatory motion, of course. But audible. Few people are writing, says, speak louder, sir. I am speaking in front of a laptop. I hope it is audible to you. With normal pitch only I am speaking. Okay. So there are some examples here for oscillatory. You can identify oscillatory motion. Spinning of top does not come under. Bullet fired from a gun also does not come under. Typewriter keys. Anyway, these days we are not using typewriters. Therefore, you may not observe, but they move up and down. Oscillatory motion. Motion of the Fartos wheel. That is also rotatory motion. Motion of a vibrating sitar string. This comes under oscillatory motion. Motion of a car taking turn while moving. This is a curved path. Translatory motion. Ringing of a bell and bouncing of a ball. It moves up and down. So now we are coming across to compare the speed. Speed, when we are, what is speed? Which is moving faster and which is moving slower, that we have to see. Which is moving faster and which is moving slower, that we have to see. Slow motion and fast motion. How do we understand this? To understand this, we have to compare with another uh, component called time. So thus we understand that distance traveled by an object in a given interval of time can help us to decide which is faster and which is slower. So if the same amount of time decide, see, here we are coming across another word, time. What is time? Now we say that the time is around, I don't know, 5:45 or some, I cannot see time here. 6:46. So when the same time is given, if an object takes less time or moves more distance, same time is given, the object covers more distance, then we say that it has more speed. More speed, slow car, fast speed, fast moving. What words are here using? Compare. Slow motion car, fast motion. If it is covering less distance in more time, then we say it is slower. So slower and fast also are relative words. Slower and fast also are relative words. అది కూడా మనం టైంని బేస్ చేసుకొని రెండు ఆబ్జెక్టులు ఉన్నప్పుడు ఒకదానితో ఒకటి కంపేర్ చేసుకొని చెప్తామన్నమాట. అప్పుడు అది కూడా కంపారిటివ్ టర్మే. సో హియర్ different kinds of motions we could come across. And now here we are trying to understand time. What is time? How do we understand time? That is where these days more so many from the beginning of arise, awakening from the bed up to going to the bed, we are running after the time. What is time? So we use the word time very often in our daily life. So many ways we use, but what is time? So how to understand it? How to estimate time? So without using the word time, express the duration of time like so late, so early. So we are comparing. So how can we define time? Measurement. We can how to understand time? We shall see. So this is in what to say, gap between two incidents happening between two incidents. Time is usually expressed the time, the gap between two incidents, whether the incidents may be very long, the duration between two incidents may be very long or very short. But the duration between the two incidents, we call it is as time. So usually we measure time with different devices. Usually we call them as clock or watch or whatever may be. Like so, we use some units to express. So years, months, days, time for hours, second, minute. So whatever it may be, time says the duration between two events. Duration between two events. How to understand? Let us take a simple, here the table has given, let us ringing of long bell in the school. ఎప్పుడెప్పుడు కొడతారు ringing of the long bell? డ్యూరేషన్ ఈవెంట్ ఈజ్ రింగింగ్ ఆఫ్ లాంగ్ బెల్ ఇన్ ద స్కూల్ 2 times కొడతారు, ఒకటి మార్నింగ్ ఇంకొకటి ఈవినింగ్, ఈవెన్ ఇంటర్వెల్ టైమ్ దే మే బి. What is the duration of time? How can you compare? Completion of prayer song, how much? From the beginning of the prayer song to the ending of the prayer song, 2 incidents. Running of 200 meters by your friend in the school ground, you see. Beginning of starting running race and ending the running race. So this is 2 incidents. Completion of pledge during the school assembly, starting of the pledge time and ending, how much time. Right, try to make a note. So how to measure? If you want to compare one unit, you should have a standard unit to universally understood. ప్రపంచం మొత్తానికి ఒకేలాగా అర్థం కావాలంటే యూనివర్సల్గా అర్థమయ్యేటటువంటి యూనిట్స్ మనకి ఉండాలి. మరి టైంని ఎందులో కొలుస్తున్నాం? టైంని ఎందులో కొలుస్తున్నాం? సో హియర్ టైంని మనం సాధారణంగా there are so many units to say a day, year, month, week, and all, whatever it may be, but unit of time, usually, depending on the context, we express time in seconds or minutes or hours to specify the occurrence and time taken by an event. ఒక ఈవెంట్ టైం ఎంత తీసుకుంటుంది అనే దాన్ని బట్టి బేస్ చేసుకొని టైంని మనం ఎట్లా బేస్డ్ ఆన్ ద యూనిట్స్, బేస్డ్ ఆన్ ద సిచ్యువేషన్, we based on the depending upon the context, depending upon the context, we express time in seconds, minutes, or hours to specify the occurrence. But usually the basic units of time, large units of time are minutes and hours, whereas basic unit of time is second. అంటే సాధారణంగా మనం టైంని చాలా సందర్భాల్లో తక్కువ, బికాస్ వి కంపేర్ విత్ ద టైం షార్ట్ ఇంటర్వెల్ చాలా తక్కువ ఆ వ్యవధిని తీసుకునే టైం గురించి మాట్లాడతాం అన్నమాట. కాబట్టి చిన్న యూనిట్ సాధారణంగా మనం టైంని సెకండ్లో కొలుస్తాం. అలా కాకుండా మనం కొన్నిసార్లు కిలోమీటర్స్ పర్ అవర్, ఒక స్పీడ్లో గంటలో ఎంత వేగంగా పోతున్నాం, ఒక మినిట్లో ఎన్నిసార్లు తిరుగుతుంది. ఫర్ ఎగ్జాంపుల్ రొటేషన్ ఆఫ్ ది ఫ్యాన్, ఒక నిమిషంలో ఫర్ మినిట్ ఆర్పిఎం అని అంటాం. ఆర్పిఎం, వాట్ ఈజ్ ఆర్పిఎం? ఆర్పిఎం అంటే ఏంటి చూద్దాం. ఇదేంటి, వాట్ ఈజ్ ఆర్పిఎం? ఆర్పిఎం రొటేషన్స్ పర్ మినిట్. సో అక్కడ మినిట్లలో కొలుస్తున్నాం, అవర్స్లో కూడా కొలుస్తున్నాం. లాంగర్ యూనిట్స్ అయితే చూడండి, లాంగర్ అనగానే మినిట్ అయిపోయింది, 60 seconds. But how many seconds is equal to 1 minute? That is a basic unit structure you should know. How many minutes is equal to 1 second? Sorry, how many seconds is equal to 1 minute? Says ikkada ichinaru table ichinaru. Time table, units of time, a tabular form it is given. See, 60 seconds is equal to 1 minute. 1 minute, to be 1 minute, we need to pass 60 seconds. 60 minutes makes 1 hour. 24 hours make 1 day. See, a sequence is given. 1 millennium. What is 1 millennium? That is 10 centuries. Century means 100 years. 100 years is equal to 1 millennium. 10 decades. Decade means the decade. 10 decades gives you century. Up to now, we are trying to measure time. Time is the what is it? Difference between the two incidents, two events happening. There are two events happening. Time can be expressed in two different. Time can be expressed with different units, but in a laboratory, usually we use time in seconds. Okay. Hmm, which is a good device to measure time. We are using so many devices to measure time. Which device helps us? Which device help us to measure time? Though there are so many devices as on today, see, so many clocks we have to estimate time. Not we are measuring up to say in another way, we are estimating time. Okay. What are those? Like minutes and hours, week, fortnight, month, season, annum are also units for measuring time. But to measure this, what are the clock? How do we measure? Time is measured with the help of clock, sand clock, water clock, sundial, etc. Were used earlier instruments for estimating time. So we are to say uh, we shall estimate the time, not to measure the time. But though we have been trying to estimate the time for longer days, for a longer period, still we are unable to estimate it correctly. Okay. So here to measure time, the time is different in different zones on the earth, in the fields. So usually, uh, when we speak about the time, now in India, time is around 6:40 or 6:56. But in America, in Australia, in Iran, England, how what will be the time? So we are trying to measure the time from midnight today to the midnight next day. That has been made into 24 equal parts. Each part is divided into 60 equal parts. That is still divided into 60 equal parts. That is known as second. Second is usually we say it is the smallest unit, but these days we are also measuring milliseconds. Still further smaller units to estimate time. We are estimating time. We use using stop clock. In a laboratory, when we are conducting an experiment, we are precisely trying to get correct time. Okay, correct time, and we are estimation should be equal. So we use even in our cell phone. See here, there are timers, two timers. But our timer, even the cell phone, we will have timers. The time is divided into smaller units, smaller parts. So nowadays we find the stop clocks almost in all cell phones. In our daily life, stop clocks help measure pulse rate, etc. Apart from this, they also help us accurately measure the time in running races, swimming races, etc. సో ఇక్కడ మీకు స్టాప్ క్లాక్ అనేది ఇక్కడ చూడొచ్చు మీరు ఫిగర్ నెంబర్ 33 ఈజ్ అ స్టాప్ క్లాక్ అండ్ ఇట్ ఈస్ అ రిస్ట్ వాచ్. So usually nowadays we use different instruments like electronic clocks, digital clocks, quartz clocks, etc. to measure time. These are the different kinds of clocks. Analog and digital. Analog means which has hands. Digital means which, okay, now digital means which gives the numbers. Now the time is running out, so let me stop for today. Okay, I'll stop sharing. We will continue in the next class. Thank you very much for joining me.